and welcome to this video. In this course, you will learn everything you need to know to get started with the Dart programming language. So even if you don't have any programming experience, there's no problem. This video is designed for absolute beginners, and I assure you that is a very good first programming language. So without further ado, what is Dart? Dart is a general purpose and object-oriented programming language. It was developed by Google back in 2011, and it was initially used within the company. Now, the language was not popular until Google made it its official language to develop cross-platform mobile app using the Flutter framework. So, the language compatibility with Flutter was so good that the use of Flutter has gone beyond just cross-platform mobile app development, but also web development, desktop app development, and even server-side development. So that is easy to learn, understand, and use for any purpose you'd like to use it for. So the next thing we are going to do now is to set up our development environment, which means where we are going to be writing code. So to do that, we can download Flutter or to download the Dart SDK. But downloading Flutter will automatically download the Dart SDK, meaning when we download Flutter, the Dart programming language comes with it. But in this video, our focus is on the Dart programming language, so there is no need for us to download Flutter. So for this course, I would recommend you use an online text editor, and we'll use the official Dartpad text editor. I already have Flutter downloaded on my system, so I'll be writing my code on my local machine. So if you don't have an environment set up for that on your system, you can use an online text editor like Dartpad, or there are other text editors like Replit, which is also a great online IDE. So I'll be using my local machine to write code. So without wasting your time, let's dive in and see what we have. So the first thing we are going to do now, we've created a folder called Dart class, and we've opened it using VS Code. So the first thing we are going to do, just to see the basic syntax of Dart, let's create a file called hello.dart. So now we have a file named Dart, hello.dart, and the first code we are going to write is void main. And let's run it. So to run it, you just need to come down here and you see the run button right up here beside the debug. Click on the run. So when we click on run, it brings the debug console. Now if you have Flutter downloaded on your system, don't click on this play button right here, because when you click on the play button right here, what you are doing is building a Flutter project, and that's not what we want. We want to focus on that, the programming language. So click the run right above the main function right here, and you see the output in the debug console. So let's unpack everything we have just written. Void is used to indicate a function that does not return a value. So don't worry about function for now. We'll talk about functions in detail later in the course. Now main, which is this function right here, this name right here, it is the topmost level function in the Dart programming language. And by this, it means this is where our code begins to execute. It is the entry point into our code. So that means even when we declare things like variables and other functions outside of this function, they can't execute on their own. They can only execute when we use them inside the body of this main function. And what is the body of this main function? That is where we are going to next. So you have this curly braces right here. So the curly braces indicates the body of the function, and this is where we declare the functionalities of the function, call things we need to call, declare variables, declare functions, and basically functionalities inside this place. Now the parentheses takes what we call parameters, but for main function we are not going to be using it for now. when we get to functions later in the course, we are going to talk about parameters and you'll understand how we use them. So the print function right here, print is a function built into the Dart programming language. And what it does is it helps us to display things in the console right here. So when we run this code, the reason we are able to get hello world down here is because we use the print method. Okay, so using print, it displays what we write inside the parentheses in the console. So the semicolon is needed to signal the end of a statement. For instance, if we remove it, we get an error. Let's run it and see what we get. So click on run, show error. It's expected to find, because as far as that is concerned, it does not know whether we are done with this statement. So adding a semicolon solves the problem. So now when we run again, we get hello world. So now for this course, I want us to create a separate file for each of the topic we're going to be talking about. This course, we are not going to go really deep, but I want to make sure we touch each and every concept we need to touch. And to do that, we are going to create a file for each topic and concept. So the first thing we are going to talk about is expressions, statements and expressions. So once again, let's create another file and say statements. Statements.dart. So in that, when we do something like this, let me create a main function. So say void main. So when we do something like this, var a equals 1, var b equals 2. These are all expressions, okay? We are not doing anything specific. We are not telling the computer to do anything specifically. On the other hand, when we say statements, okay, let me comment them. Say expressions. Expressions. So statements, on the other hand, is when we tell the computer to do something specifically that we want it to do. So when we print, we can say print hello world like we did earlier. So print hello world. This is statements. We are telling the computer to print something out for us to see, to give us an output. We can also say print a plus b to print the sum of a and b, right? So now when we run the code, we get the statements hello world and 3, because these are what actually tell the computer to do something, not the expressions. So the expressions, we are simply saying assign the value of 1 to the variable a, assign the value of 2 to the variable b. And now the next thing we are going to talk about is variables, right? So let's create a file for variables, and we'll say variable .dart. Create your main function. So now variables are used to store data in memory. So you can think of variables as containers with a name on them. Remember the variables we declared earlier. Var a equals 1, var b equals 2. So what that means is the value of a is stored inside, the value of 1 is stored inside a. So variables are like containers with a name on them, and they store a value that corresponds to that name. So every time we need to make use of that value, we take the name of the variable. So we can declare variables using different keywords, right? And the most common one we can use is called var. Variables declared with the var keyword can hold any data type. Now, the data type of the variable will only be inferred by the compiler based on the value assigned to the variable at runtime. So when we say var greet equals hello, we can print great. Can print great. And then there is another variable called dynamic, another keyword called dynamic. So variables declared with the dynamic keyword can hold any type and can also be reassigned to a different type. So let me tell you what that means. So when we create this variable right now and we run it, we can run. So we can reassign it to another string. So we can say great equals hi. Great equals hi, right? So when we print great this time around, we're going to get hi. So let's save, run the code, and we get hi. So now when we take great and assign it to a number, print great. So now there's a problem. Even without us running it, you can already see the squiggly lines under it. And when we hover over it, you can see the error. It says a value of type int can't be assigned to a variable of type string. Okay, so this variable, our compiler already knows it holds a string value. So the variable is already a string variable. Now trying to reassign it to an integer value is a problem. So when we still go ahead and try to run it, we get an error. It says value of type int can be assigned to this and that. So this is where dynamic comes in. Variables declared using the dynamic keyword can hold any data type and can be reassigned to a different value anytime we want, a different value of a different type. For example, when we go ahead and say let's remove this great equals to, yeah, so we can say dynamic my var equals okay, let's say hey. Now this is a string. Let's print and see what we get. Print my var. So we get hey. Now because it is dynamic, we can change the type. We can reassign it to a different type. Okay, not really change the type, but we can reassign it to a different type. So now we can take my var and say my var equals 34, right? So when we print my var, what do we get? We get 34. So unlike var, dynamic can be reassigned to a value of a different type. Then we can also declare variables using final and const. So variables declared using final and const keyword are constant variables, which means they cannot be reassigned like we've done here. So here we say my var equals hey, and we reassign my var to 34. So variables declared using final and const cannot be reassigned. However, the way they work are different. Variables declared using the final keyword are evaluated at runtime, whereas variables declared using the const keyword are evaluated at compile time. Okay, this is the difference. So let's come down here and say final x equals 1, const y equals 2, const y equals 2, and we can print their values. Print x, print y. So when we run the code, we get exactly what we want. We get 1 and 2. However, when we come down here, we cannot reassign these values anymore because they are constant variables. So when we say y equals 6, so you can already see the error down here. It says constant variable can't be reassigned to a value. Try removing the assignments. Then this one, it's also say final variable can only be set once. Okay, so both of them cannot be reassigned. Right guys, that's all for variable, and you can remove these two actually to make sure there is no error left in your code. And the next thing we're going to talk about is data types. So let's come down here once, come up here once again and create a new file, data type dot start. So now in programming, we manipulate data all the time. As a matter of fact, programming is basically about manipulating data. And we must know the kind of data we manipulate, the kind of data we are using, and the operations that we can perform on these data. So in that, we have several data types. And that is actually a statically typed programming language, which means you can declare variables using their types directly. So let's create our main function. Now the first data type we're going to talk about is int. Okay, and int is short for integer. It is used to represent whole numbers like 23, 35, 10,000, 1 million, for example. We can even create a variable called age. Its age equals 25, right? So we'll print age. Print age and run. Now it is not really necessary to use the type, but there are certain times it's helpful to use the types directly. So the next data type is double, and double simply denotes numbers with a decimal point. Okay, for instance, we want to talk about the rate of inflation, so we can say double rate equals 2.65, yeah, 2.65. So print rate. So we get rate. And then the third data type we're going to talk about is string, and we've already used strings already. Hello, hi, hey, that we've done earlier. So string is a data type that represents alphabetical characters, and not only alphabetical characters actually. It represents any character that are inside quotation marks. Okay, any set of characters inside a set of quotes is a string. So it doesn't matter if it's alphabets or numbers or anything. So, but it mainly applies to alphabets because alphabets can stand on their own, like we have 25 and 2.65 here. So the first one we're going to look at is name. So let's say string name equals Cornelius. Can't spell my name. So we have string name equals Cornelius. Oh, sorry. I think it is uppercase. Yeah, string is uppercase. So we'll print name. Now we get my name. So like I said, it also applies to, let me run it so we can see. So you get 25, 2.65 and Cornelius. So like I said, it also applies to any other set of characters that are enclosed inside a set of quotes. So we can say string amount equals 5 point, sorry, 5.4 liters. 5.4 liters, right? So now we'll come down here and print amount we get exactly what we want, 5.4 liters, and we have no problem, even though technically 5.4 should be a double, right? And liters is a string because it's alphabetical characters, but because they are both enclosed inside a set of quotes, they are both classified as strings. Now the next type we're going to talk about is bool, short for boolean. So bool is the data type that specifies any value that amounts to true or false. Okay, is it raining? Yes or no? But in programming we usually use true or false. So we're going to check if 5 is less than 2. So let's say we want to check bool check equals 5 less than 2. So print check. Let's save and see what we get. So you see the value is false. 5 is not less than 2. So when we change this lesser sign to greater, of course 5 is greater than 2, so now we expect to see true. So now we expect to see true. Okay, the next type we're going to talk about, and this is actually the last type we're going to talk about, is num. Okay, num, and it stands for numbers. It is the parent data type for int and double. It acts like dynamic, but unlike dynamic that applies to all the data types, num stands for only int and double, which means when you create a variable as int using num, you can reassign it to a double and you won't have a problem. So let's come down here and say num x equal to print no print x rather, not num, and we can come down here and reassign x equal 4.656. okay, so now we can come up again and print x, and we won't have a problem because num applies to both int and double. So let's run the code and see what we get. So we get 2 and we get 4.56. But remember, when reassigning variables, you must reassign them to the value, to the same type. Okay, so strings should be reassigned to strings, and integers should be reassigned to integers. Double should be reassigned to double, unless in cases where you use dynamic, or for int and double where you can use num. Okay, so now the next thing we are going to be talking about for the next section of the course is string methods. Alright guys, so we are going to go into string methods now. Oh sorry, I think I should increase the font size. I don't know how small this is going to be, so let's come here and increase to 23. Let's see. So I think this is okay now. Yeah, sorry, I'll check if the previous one I've done are too small. If I need to remake the videos, I'll know. So the next thing we're going to talk about is string methods. So let's say string methods. String methods.dat and create your main function. So string methods are a set of functions that are built into that, and they enable us to manipulate the output of strings. So let's take a look at a few of them. First, we're going to create our string and see what we can do with it. String river equals Amazon. So this is the string we're going to be trying our things on. So remember, variables can also be declared using double quotes, but they're mostly that I think double quotes is deprecated, right? I think it's deprecated. We can say fruit. I think double quotes is deprecated in that. So fruit equals apple. Okay, you can declare strings using double quotes. Okay, there are also multi-line strings, and multi-line strings are strings that can span across two or more lines. So let's create a multi-line string, and we can say story, string story. String story. So a multi-line string will be inside quotation marks, but you have to make it 3 on each side. So we'll say this is let's go to the next line. Multi-line. Let's go to the next line. String. And now that's the end of our string. So we have a multi-line string. So let's print all 3. Print river. Story. So now let's go ahead and print all 3 and see what we get. So you see Amazon, Apple, and this is a multi-line string. Okay, so the first string method we are going to take a look at is the to uppercase. So to uppercase converts all the characters of a string to uppercase. So let's do this and say print our river to uppercase. Then for us to use the method on it, we're going to use what we call the dot notation, and that is by adding a full stop or dot in front of the string variable. So we say, or it could also be a string literal, whatever you want to do. So we can say river dot to uppercase. We want uppercase. And when we save and run the code, what do we get? So now river will be printed in all caps, okay, because we've converted the string to uppercase. And now this will only print river in uppercase once because we are only using it here. But if you need to use it multiple times, you can then assign this output to a variable. Okay, we can set it to a variable. For instance, you can do something like this and say instead of print directly, you can just do x equals print to uppercase, sorry, string x dot print dot river dot to uppercase. So print x. And when we save now, this time around, so this time around we have Amazon uppercase as a variable. So anytime we need to use Amazon uppercase, we can use this x right here. So another thing we can check uses, another method we can use is called contains, right? So contains checks if the string has a specified character. For example, we can check if a variable has the letter M in it. Okay, so let's check if it does. We say, sorry, var M. Let's even name the variable as M. So we say river that contains M. And of course river does contain M. So what do you expect to see? We get true. Okay, so the output of contains is the output is a boolean. So if it contains the specified character, we get true. If it does not, we get false. So let's see if Amazon contains the letter B. Of course it doesn't. So let's save it and run the code. And now we get false because Amazon does not contain the letter B. So after the contains method, the next method we are going to talk about is substring. So with substring method, we can create a new string out of an existing string. So with the substring, it takes some of the elements of a string and creates it in a new string. So in programming languages, or at least some programming languages that I know, the index of a string always starts at 0. So when we go ahead now and do something like this, let's say print river dot substring. Okay, river dot substring, and now it's telling us to start. So we're going to start at 0. It starts at 0. Okay, so we start at 0, or let's use 1. Let's start at 1. So from 0 to 4. Okay, so let's save and see what we get. So now we get mass MSA. So it starts from here. This first A is 0. So the 1 starts from M, 1, 2, 3. So it stops as a character before the specified one. So it's not going to stop at 4. It's going to stop at 3. Okay. So if we want to include 4, then we need to put 5 there. So there are also some properties that we can use for strings. So properties are different from methods, and I'm going to explain these things a little bit more when we get to classes later in this video. So how to identify a property from a method? Anything you want to use and you have to put a parenthesis in front of it is a method. Okay, and by method we mean a function inside a class. It's called a method. So when we start creating our own functions, we are also going to be using them this way by having a parenthesis in front of them. So methods built into that, to use them, we need to implement them using this parenthesis. So let's go ahead and see some properties, some string properties in that. And one we're going to look at is called length. So length simply returns the number of characters in a string. So let's go ahead and say print fruits dot length. So you see, we don't need to use a parenthesis in front of it. So let's save. And what do we get? 5. So let's count it. 1, 2, 3, 4, 5. So we have 5 characters in Apple. So we also have another property called isEmpty. And isEmpty returns true if the string is empty, and it returns false if the string is not empty. So let's do something like this. Let's say var name. But do we have name already? Okay, no we don't. So var name equals an empty string, right? So let's print name. So print name dot is empty. So we get nothing. Now we are going to print name dot is empty. Okay. So to confirm if truly it is empty, and then when we come up here and run it, we get true. Name is empty. So in conclusion to this string section, we're going to be talking about string concatenation. And this simply means to join two strings together, two or more strings actually. So here we have 3 variables declared. The first one is variable A, which is declared assigned to hello world. Hello world is assigned to variable A. World is assigned to variable B. And we have C, which we use to concatenate the 2 previous variables A and B alongside a message that variable C is holding. So when we run this code, let's go up and run it. I'll see. We get, this is a hello world message. Okay, by adding this plus sign here, we are able to place the strings beside each other. However, there's a better syntax for us to do this, and it takes away the complexity of the plus sign, which can occur if you are concatenating more than two strings, and this can easily get messy. So the better syntax is to use what we call string interpolation. So with string interpolation, we do something very simple. We say var, let's say var d equals this is a B message. So now when we run the code, we still get the same message. This is a hello world message, but now with string interpolation, we don't have to use multiple plus signs. So another thing with string interpolation is if you want to add the string methods to the variable you are interpolating with another string, you can put it inside curly braces. For instance, if we want to do a dot to uppercase, a dot to I've forgotten the uppercase, how to write uppercase. Okay, a dot to uppercase. Okay, yeah, uppercase. So let's save and run the code. Right now you see there's a problem. This is a hello dot to uppercase, and that is not what we want. So to solve this problem, we can simply put this entire string plus the method inside curly braces. Okay, with the $sign outside, we put it inside curly braces. So now it will invoke the function, and when we save and run it, we get this is a hello world message. So if you're going to be adding a method to any of the strings, you can simply place it inside curly braces. So now you can see that with string interpolation, it is easier to implement instead of using multiple plus signs in with the string concatenation. So we are going to go into the next section and take a look at data collection. So please, a sub to the channel will be very much appreciated. So the next thing we're going to be talking about is called lists, and it is the most commonly used data collection. So let's create a file, list.dat. So a list is a collection used to store items or elements. Okay, it's more like a variable, but a variable that holds multiple values. For instance, let's create a list of animals. Let's create our main function. I can't spell me. So we'll save our animal equals, and the syntax is you set the animal equal to a square bracket, and inside the square bracket we add what we call elements, each of the individual values. So let's add cow, an owl, and a cat. Why not? So when we print animals, what do we get? So we get a list of cow, owl, and cat. So the list uses a zero-based index, okay, just like strings. And this means that the first element in the list is at index 0. So element cow is at index 0, owl is at index 1, and cat is at index 3. So if we are to count it, we have 3 elements inside the list, but by index we're going to start 0, 1, 2. Okay, so using the index of the elements, we can now use the individual elements instead of the entire list. So instead of printing the entire list, we can come down here and say print animals. animals, and in front of animals, let's print owl. Okay, so we put index 1. Oh, sorry, animals. Okay, so save, and when we run the code, we get owl. So this way we can have an element that contains multiple elements, an array that contains multiple elements. It is called array in some programming language, so I keep making that mistake, array, but in that we call it list. So we can have a list that contains multiple elements, but with using this index, we can now access each individual element. Okay, so we can also take it a step further and use this thing in a sentence. So we can say print let's say print, and we're going to use a string interpolation. So we say string animals, and we put 0 inside it. So it's grass. So now we get cow eats grass. So lists also have methods available to them, which we can use to manipulate the output of lists. And now we are going to take a look at some of those list methods. And this makes it easy to perform certain operations on lists. The first method we are going to look at is the add method. So add, just like the name, helps you to add an element to the list. So let's say animals dot add let's say lion. So when we print animals now, we get lion as part of it. So let's run. So you have cow, owl, cat, and lion. We can also use add all, and add all works just like add, but unlike add, we can use add all to add multiple elements to the lists. So let's say animals.add add all. Actually, animals.add all. I would say eel. Okay, let's create a list inside it and say eel duck. Let's just come up with something. Dog. Okay, that's all. Let's stop with dog. And we put a semicolon, print animals. When we save and run, we now have multiple elements added to it, eel and dog. So we can also check if an element is empty. This time using the property is empty. I think we've used it earlier with strings, but it's also available for lists. So we can say print animals dot is empty. That is empty. When we save and run, we get false because animal is not empty. Animal has about 6 elements in it. So we can also use the reverse method. So reverse method reverses the order of the elements inside the list. So let's just Ctrl D and yeah, reverse. Is it a method or a property? I don't know. Okay, it's a property, not a method. So we also have the clear method, and clear is used to remove all the elements inside a list. Okay, so when we call the clear method on a list, it clears out all the elements inside the list and you have nothing else inside the list. So let's call animals.clear. Print animals. So now we have nothing. We just have an empty list down here with no elements inside it because we've cleared everything. So the next thing we are going to talk about is spread operator. And for spread operator, I think we should just use it inside the list here. We are not going to be creating a separate file, but I'll just write a comment here, spread operator. And what the spread operator does is it helps us to insert multiple values into a list. But unlike add all, it is mainly used to insert the value of one list into another list. So the syntax is 3 dots, then the name of the list you want to insert. So let's remove this clear, or let's create 2 new lists. Okay, so we're going to say var x equals 1, 2, 3. Okay, so let's print x. Now we're going to say var y equals, let's say 4, 5, 6. 4, 5, 6. Then beside the 6, let's add x. So we are going to use the spread operator to add x. And you can see it already brings the x for us. So let's save and print y. So when we save, what do we get? We get print x, which prints the properties of x. And now with the spread operator, we see that the elements of x has been added to the y list. So we can use the spread operator anywhere we want, not only at the end, we can also add it at the beginning. For instance, let's remove this from the beginning and put it from the ending rather, and put it in the beginning. So we have a good order of 1, 2, 3. So let's save and run the code. So there you have it for the list. Alright guys, that's all for this video, and in the next lesson we're going to talk about map. So let's end the video and create a new file here and call it map.dat. Okay, so map, just like list, is a data collection, or let's say a collection of data items. But for maps, we do it in the form of key value pairs. Okay, so we have a key and the value corresponding to it, almost like the way you set a value to a variable, but it's not exactly the same way. So let's see an example. Let's create a void main. That is our main function. Before we can do anything, we always need to create a main function. So inside, let's say var students, or let's just say students equals, and the syntax is to use a curly braces. Okay, so the first item we're going to add, key value pair we're going to add, is id 1. So id is the key, 1 is the value, and you're going to separate them using, I think, a comma. Okay, using a comma, and we say first name, let me put it inside quotes. First name is let's say John, and last name is Doe. So there you have it. We can also create we can also have the value as a map. Okay, so instead of us just creating one key, one value, we can also do it in such a way that each key has another map as a value. So let's do something like this. Let me break this down. so it's easier for us to see. So let's say we want to go for subjects, right? So subjects is the key. Subjects is the key, but the value is also another map. So inside this value we now have things like maths, let's say physics, and you can add as many as you want. In fact, you can come out here after this, you can also add another key value pair outside this one and say, let's say gender is male, the gender is male. So let's save. Let's save and print students. So let's print students. So when we print students, we see first name, we see last name, and inside the subjects we get maths and physics. You can add as many subjects as you want, but for time I'm going to just use this. So maps also have properties that we can use on them. So let's say we want to print just the keys. So we can say print students, the keys. So this way we get only the keys: ID, first name, last name, subjects, and gender. So we can also, after keys, the last property we are going to talk about is length. So let's just say print students dot length. And when we save and run the code, we get 5. So it counts it based on the keys. So ID, first name, last name, subject, and gender. So we have 5 key value pairs. Okay, so that's all for maps. And in the next section, we are going to go into a very important concept in that and programming generally, called decision statements. And that's where we're going to be doing things like if and else statements. And that way we'll be able to write codes that are more intelligent and be able to make decisions based on certain conditions. Alright guys, thanks for watching, and I'll see you in the next one. In this section, we're going to talk about decision statements. So we'll write a program here that helps us to check if someone is old enough to vote, right? So I believe the voting age varies in different countries, but here in Nigeria, we just held our election last week, the presidential election, and the voting age is 18. So if you are not up to the age of 18, you are not eligible to get a voter's card and you are not eligible to vote. So now for this code, we are going to write a program that checks if someone is old enough to vote. So the first thing we're going to do is set age, create a variable for age, where age equals, let me say 18, right? And after setting our age equals to 18, the first decision statement we're going to look at is called the if statement. And with if statement, we simply check only one condition. If age is greater than or equal to 18, so we're going to print you're eligible to vote. So let's run the code and see. Now, based on the condition we set, an age is equal to 18. So we say if age is greater than or equal to 18, it should print you are eligible to vote, and it does. So what if age is less than 18? It's not equal to 18 and it is also less than 18. So let's run the code, and what do we get? We get nothing down here. Okay, nothing is printed to the screen. But we still want to get an output. So that will make it easier for 17-year-olds to know that they are not eligible to vote, right? It would be rude for someone to just ask a question and we leave them hanging without giving an answer. And the way to do that, let me copy this. Oh, there's no need to. I'll just write it beside. So we're going to say else. Else print you are not eligible. Let's add sorry at the beginning. So sorry, you are not eligible. So let's save and run the code. Let's cancel. Where's the error? Okay, we forgot a semicolon. And let's save now. And when we run the code, sorry, you are not eligible to vote, right? So now, even though the user is not eligible to vote, they still get an answer, which that way they will know they are not eligible to vote, and we do not leave them hanging. So now when running the code, again, there are times that we need to add more conditions. And this is where the statement called else if comes in. So aside from if and else statements, we can take this code even further and make sure we add a condition. Let's say we add a condition for seniors or older people who might not be able to go out to vote. So the else if statement comes in between the if and else statements. So let's go back and check this condition. So we say if, else if, else if, else if age greater than 100, or let's say greater than 90, or let's use 100 actually. So else if age is greater than 100, well, let's print you are eligible to vote, but you might be too weak. So the older people older than 100 might be too weak to go out to perform their voting exercise. So we are just going to tell them they can stay at home and not go. Eligible, but you might be weak. Weak for the exercise. So that way people older than 100 will know that it's not that they are not eligible to vote. Of course they are eligible to vote, but it's just they might be too old to do that. So let's change the age to 172 and run the code. So what do we get? We get you are eligible to vote. We do not get the code for this one. Why? Is because the first condition here, greater than or equal to 18, has override the else if. Okay, so 100 is greater than 18. It's always going to be true. So it will simply tell us you are eligible to vote. Now the best way to correct this is to say and age less than 100. Okay, so that way we will not override the else if statement. So when we run the code now, we get this because age greater than 18 and less than 100. So it cannot override the else if statement that say if age is greater than 100. So now we get what we want for someone age 172. So you are eligible to vote, but you might be too weak for the exercise. So the next syntax we're going to talk about is called the ternary operator. So for ternary operator, we can simply do something like this. Age. Okay, let me comment out all this. So this way we age greater than 18. Age greater than 18. So ternary operator is a very short syntax that enables us to do things very fast. Like if you just have a small condition you want to set. So if age is greater than 15 is the condition, and we use a question mark to specify that. So we now say print, let's say print yes. Okay, print yes, else. And for else we use a full colon, print no. Okay, so that's the end of the statement. That's the end of the statement. And when we run the code, we get yes, because 172 is greater than 100. Now, the last decision statement we're going to talk about is called the switch statement. Okay. Now, this is another way where we can write multiple if and else statements and statements that contains else if. Okay, so it's not necessarily a shorter syntax, but it is just a different syntax that you might prefer over the traditional if, else if, and else statements. So let's see an example, and I'm going to pause the video and type this whole thing because I'm not really the fastest person when it comes to typing. So here you have it. We've written our switch statement, and we use it for the days of the week. So we created a variable, set it to 2, and inside our switch statement, let's look at the syntax. So switch, of course, refer to the switch statement, and inside the parentheses in front of switch, we add the condition we want to check. So for this condition, we are creating cases, okay, like kind of scenarios. So we say when case is equal to 1, that means if day is equal to 1, right, we should print the day is Monday. And this break signifies that we've executed the code. So the compiler should break out of this switch case. It won't have to go through everything. Okay. So for each case, we get a break function. We get a break statement. That way the compiler knows it has executed the code it needs to go. So now for the day, we've set day equal to 2. Let's go ahead and run the code and see what happens. So we get the day is Tuesday. Why? Because the case is 2, and it says when the case is 2, it should print the day is Tuesday. So let's go down and see Sunday. And we are going to set day to be equal to 7. So now our day is equal to 7. Let's run the code. And the day is Sunday. So after everything, we have a default value. So just in case we have a user who decides to add a number or a case that we have not specified. So we've specified 1, 2, 3, 4, 5, 6, 7. So if a user should add a number that is unspecified here, so the default value is going to be printed. So let's make the day 77, right? So when we run the code now, we are going to get not a valid day because we don't have 77 days in a week. So let's run the code and see not a valid day. You understand? All right, everyone, that's all for switch statements. Okay, it enables us to switch between conditions and see if the condition is true, then it prints out a particular statement, and if the condition is not, it prints another. So that's all for decision statements. And the next section we are going to go into is the way we are going to try to iterate over all these things. And the name of that section is called loops. So loops enable us to run a piece of code repeatedly until the condition is met. And in languages like that, there are different types of loops, and we're going to take a look at each one of them. So let's go and create a new file, I'm just going to close some of these files here, including map. I don't think, and decision statement, we don't really need it. So we're going to create a file called loop.start loop.start. So the first loop we're going to look at is called the for loop. So let's create our main function. So the first loop is for loop, and it is the most popular loop we use. So for loops execute a code a specified number of times. Okay, it executes a piece of code a specified number of times until the condition is fulfilled. So let's see an example. Let's say for, and I love VS Code, it comes with some shortcuts that we can use to specify certain things. So it comes with count. Now you can set a variable to this count, or you can just say you can just set the value directly. So let's say count equals 10, right? So instead of using count, we can simply say I less than 10 here. So I'm going to explain what we've just written. So we created a variable called count and we set it to 10. And it is the number of times we want our code to execute, our for loop to execute. So here we say for var I equals 0. Now I represents each of the time or each of the elements contained within this 10. Okay, or each of the time this code is going to execute to count up to 10. Now the next thing is a condition. If I is less than count, as long as the number of times I as execute is less than 10, I should continue to increase I++. So now let's go into the body of the code and see what we want to do with I. Okay, so let's print I. And when we save and run the code, what do we get? We get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so if for instance you want it to count up to 10, then you can say plus 1 plus 1. So you get 0, 1, 2, 3, 4, 5, 7, 8, 9, 10. All right. So we can also print a message multiple times using the for loop. So for instance, let's say var greet. Let's create another variable and call it hi. Okay. Var greet equals hi. And what this does, we are going to print it alongside the number of times we are looping in the for loop. So inside here, we're going to say, create something like this and say print. We're using string interpolation I, and another string interpolation, we are going to put greet. So let's save and see the output we get. And we get hi from 0 to 10. It tells us hi 10 times. Okay. So the next type of loop we're going to look at is called the for in loop. First, let me create a comment above here. For loop. So the next loop we're going to look at is called the for in loop. For in loop. And for in loop works by it iterates over collections like lists that we've talked about earlier, and I think it iterates over maps also. So the code we execute for all the elements in the collection individually. So the for in loop is also useful when you don't need the index of the execution. So take for example, we have a list of animals like we did earlier. Okay, so let's say okay, let me go to list and copy animals. Yeah, I'll just copy animals. So in programming, you're going to be doing a lot of copy and paste, but just make sure it does not become a habit that you don't write code. You simply go to Stack Overflow and copy and paste. So let's say we need for in, and yeah, so we're going to say for I. You can use whatever you want to, but we always use I. In fact, since we create a list of animals, so I'm going to say animal. For animal in animals. For animal in animals, print animal. So now when we run the code, what do we get? So you see it iterates over every element in the list. It comes to cow and prints it. It comes to owl, prints it. It comes to cat and prints it. Okay. So the next thing, we don't really need to set the number of times it should execute. It will only execute for all the elements inside the list. Now the third type of loop we're going to look at is called the while loop. We've talked about for loop already. So let's say the while loop. While loop. And while loop executes a block of code as long as the condition you set remains true. So how does that work? We're going to be using count that we declared earlier. So we have count equal to 10, right? So we are going to say while count is less than or equal to 10. So the condition comes inside the parentheses. So while count is less than or equal to 10, what do we want to happen? It should print number. We should count the number. So we're going to be printing number counts. Oh, sorry, I forgot to add this in my column. So the problem we get now is because of the fact that I run the code without specifying what it should do. So as long as count is less than or equal to 10, it should print number. So it's going to keep printing because count is equal to 10, okay? And it is always going to be equal to 10. So now what do we need to do is we need to set what it should do every time it finishes executing. So we're going to say count plus plus, okay? So now what happens? It's going to execute our code and say number 1, and it comes down here, count plus plus, prints number 2, as long as count is less than 10. So when it do count plus plus number 2, number 3, number 4, till it gets to number 10, it's going to stop executing because now it has met the condition 0 equal to 1. Okay. So you get count 1 to 10, and we can even make it even more interactive by saying number 1, number 2, number 3, number 4, number 5 to 10. So let's say number so let's save and run the code. So we get number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in this example, the while loop executes as long as the condition is true. Count is less than 10. And it is true, count is less than 10 because count is 1. Okay, so and it executes until count is equal to 10. So that's how we get number 1, number 2 to 10. So the last type of loop we're going to talk about is called the do while loop. Now, the do while loop is a little bit weird because unlike other loops, the do while loop executes first. The do while loop executes first, okay, before checking the condition to know if the condition is true. So whatever the condition we set, we are still going to get an output before we know if the condition is true or not. So let's check and see an example. We're going to say do while loop. So inside the do, we're going to tell it what to do. Print print hello world. Print hello world. Oh no, it should not be inside while loop, it should be inside the do. So we have the do while loop, and the do while loop, basically it executes first before it checks the condition to know if the condition is true. So regardless, even if the condition is true or not, we are always going to get an output. Okay, so first we are going to tell it what to do before we set the condition, and which is why the name do while loop. So we're going to tell it what to do first, which is to print hello world. Then after printing hello world, before we are going to set the condition. Okay, and what should the condition be? We are going to tell it that as long as count is less than 5, so count less than or equal to 5. Okay, so for that, let's set our count here, and we're going to set it to a condition that is not true. We are going to set count to be equal to 10, and obviously, or even 100. Okay, let's use 10 because we don't want to waste our time executing. So 10, right? So count is not less than 5 and count is not equal to 5. So this condition is not true. But because we are using a do while loop, it is going to execute first before it checks the condition. So you see here we get hello world just once, because what happens is after executing the hello world, then it comes down here to check the condition if the condition is true. But the condition is not true, so it breaks out of the code. So if we go ahead now and set this count to be equal to 1, and now our condition is true because count is less than 5. So it's going to print until count is equal to 5. And for that to happen, we're going to add count plus plus. Okay, count plus plus. So let's save and see. So now we get hello world, hello world, hello world, hello world, hello world 5 times, because now the condition is true, we get the desired output. All right, everyone, so that's all for loops. And please make sure you like the video and subscribe to the channel for more programming contents. Now in the next section, we're going to be talking about functions. All right, guys, so that's all for this video, and I'll see you in the next class. All right, guys, welcome to this chapter. And in this chapter, we're going to be talking about a major concept in programming in general, not just that programming language. We're going to be talking about functions. Okay, so functions are a combination of statements and expressions that perform a specific task. Okay, and functions enables us to be able to reuse code. It enables code reusability. It makes things portable, and basically it enables us to reuse a piece of code over and over again. So take for example, when we do something like this, and we've been doing it since the beginning of this course. So let's say for function main, let's create our main function. So let's say we print hello world, right? String literal that we need to print. However, if we want to create our own function, so that anytime we just call it, we don't need to use the print every single time we can do that by creating our own functions. Okay, so and the way we're going to do that is very simple. We say void greet. You can call it anything you want, and we say void greet. And inside greet, we're going to print hello. Right? So after printing hello right now, when we come down here, anywhere we call greet, okay, so we get hello. Now let's look at this syntax once again. So we have void. I already explained the meaning of void earlier during the video, how void is used to specify a function that returns nothing. Okay, so void greet, it means void greet function is not going to be returning anything. So greet is the name of the function. Okay, and inside the body of the function, and the body of the function is the curly braces. Inside the body of the function, we are performing only a single task. And what is that? We are telling the compiler to print hello. Okay, so after that, we come to the body inside the main function. Remember earlier during the video, I explained how main is the entry point into the code. So even when we create things outside of the main function, we can only use them inside the main function if we want to see it. So after creating our function outside, greet can only be invoked inside the body of the main function. Okay, so now every time we need to print hello, all we need to do is just go with greet. Now you might think, yeah, it's just like a variable, right? But no, I'm going to tell you, it's not just like variables, okay? Because now we are going to have functions with what we call parameters and arguments. Now remember when explaining it, I've been jumping this parentheses. Now parentheses are there to make things flexible. Okay, so instead of us just saying hello, why not say hello to a name? So now let's enter a name. Okay, let's call it var name. Okay, now we've entered a name. Let's come inside here and use string interpolation to say hello to the name, right? When we save and come down here, so up here, var name is called a parameter. The value you enter into a function in the parentheses when creating it is called a parameter. Now, when using it when invoking the function or when calling the function, it is called an argument. So we are going to say hello to John, or let's say hello to my name. Okay, let's say hello to Cornelius. Right. Now let's run the code. What do we get? We get hello Cornelius. So you see, with this, our code becomes even more flexible. So for instance, we can change this code to John, or to John, yeah. We can also change it to Sam. Okay, and because it is a function, it is reusable. So we say hello to Cornelius, we say hello to John, and we say hello to Sam. Everything works well. And remember this key difference. When creating the function, it is called a parameter. Name is a parameter up here. Now, when calling the function, when we need to enter the specific name we want to use, it is called an argument. So Cornelius, John, and Sam are all arguments. And we can also have multiple parameters as much as you need for your function. Take for instance, we are creating a function that adds two numbers together. So we want to find the sum of two functions. So we're going to be saying void add. So inside the add, let's create our parentheses, and in the body we are going to create two things we want to be adding together. Int x, and you're going to separate the multiple parameters using a comma. So int x and int y. So in the body of the function, we are going to declare the operation we want to perform on the parameters. So what do we want to perform? We want to find their sum. Okay, that means any argument we pass to add, it is going to return the sum of the two arguments. So let's say print x plus y. And remember, when you specify a specific number of parameters to a function, that is the number of arguments you must pass when calling it. For instance, the add function has been specified to take 2 arguments. Now, if we go ahead and add just 1, okay, let's add 2 and see what we get. So print run, and we get 5 because 2 plus 3 is 5. So if we should remove 3 from the equation and try to run it, now you can see we already have this red line underneath here. So let's try and run it, and let's see the error. It says 2 positional arguments expected, but 1 found. Okay, and it's going further to explain. It says not enough positional arguments. Try adding the missing arguments. That means it expects 2, but we give it 1. So now we're going to add 1 and save. And what you get, we get 3. Right? So there you go, we get 3. Now inside functions, we can also use a keyword called return. And return is used to return the output of a function. For instance, the print method is technically not returning an output. It is simply printing. And the print method is good for debugging and displaying things to the console. But for other operations, the return keyword is recommended. For instance, we can use the return keyword in the add function. And by doing that, we can do something like this. Let's say, let's remove the print and say return x plus y. Okay, so return x plus y. Now we get an error because we've initially declared it as void, and void is a function that returns nothing. So we need to change it to the type of data it's going to be returning, which is an integer. So we say int add, and now you see the error is gone. So inside here, to use add, we are going to use print. Okay, so the return keyword returns it, and the print displays it in the console. So let's save, and now when we run the code, we get 3. Same answer we want. Let's change the 1 to 2 and run the code, and we get 4. So remember that the number of arguments you pass when calling the function must be equal to the specified number of parameters, or else we're going to get an error. And for example, which I already did, calling the function with just 1 argument is going to result to an error. Now, there are situations where you might declare 2 parameters or more parameters, but you are not sure if you are going to use both. And that is where the concept of optional parameters comes in. Now, the syntax for optional parameters is simple. All you need to do is to specify that one of the parameters is not going to be used, or it's not compulsory to be used. So for instance, let's have another function that is going to print the name of a user. So let's say string, because we want the function to return something, right? So we're going to be using the type. So we're going to say string first name separated by a comma, string last name. But to specify that it is to specify that this is an optional parameter, we need to set it inside a square brackets. Okay, so we're going to say string last name. Okay, because we are not sure if it's going to be taking a value, let's set it to var. Okay, so now inside the var we have return. Now for the return, we're going to say for the user, my name is, using string interpolation, first name last name. And that's what we have to do. So when using this function now, it's not necessary we use the last name. Okay, so unlike the add function where it is compulsory for us to use the to, here in the user function we are not going to use the to if we don't want to. So let's come down here and say user print user, right? So you see, without even going, it simply tells us to add the first name because the last name is optional. So for first name, let's add Cornelius, right? And optionally, I might add the last name, and the last name is Maman. So let's run the code and see the output. And we get my name is Cornelius Maman. So when I remove my last name now, we still won't get any problem because the last name is optional. So you see, my name is Cornelius, and it specifies null for you to know that a last name should be there, but it's not, and it's fine, it's optional. Okay, so now if we go ahead and what else do? We can also use if and else statements to make functions even more interactive. So let's go into our user function. And inside the user function, we are going to remove these statements and use if and else statements to make it more interactive. So let's say if, I think this is an if else statement, if last name is equal to null. Okay, remember it is null down here. So we're going to be using that null, and we'll say if last name equal to null, and by null it means last name was not provided. So it should return my name is first name, right? Else it should bring my name is both first name and last name. My name is first name, last name. So when we save now and run the code again, we are not going to get null. Okay, we are just going to get my name is Cornelius, and we can also write another function where we provide both the first name and the last name. So let's provide the last name again and save. When we run the code now, we're going to get my name is Cornelius and my name is Cornelius Mama, because now the optional last name has been provided. Now, instead of optional parameters, well, we can also have a default parameter. Okay, now this is a case where we set a default value for a parameter, and the syntax is the same as that of the optional parameter, just that the parameters inside the square brackets will be assigned to a value, and that value will be the default value. So for instance, we can say okay, let's say void multiply, and inside it we're going to say int x, and to specify the default parameter, it also goes into a square bracket. So we say var y, but we are going to set it equal to a value equal to 2, and inside the body we are going to say print, x multiplied by y. Okay, so let's save now and come down here and see how it works. So when we say multiply 2, right, let's come down here and multiply again 2, 5, and let's save and run the code. What do we get? So even during the first place, when we add only 2, it multiplies it by the default value of 2 up here. Okay, then in the second place, we overwrite the default value by adding 5. So now it's going to multiply 2 by 5, and that was how we got 10. So for the first one, we got 4 because 2 multiplied by 2 is 4. And in the second place, after overriding the 2 with 5, we get 2 multiplied by 5, which is 10. And we also have the concept of anonymous functions. Okay, now anonymous functions are functions without names, and that is the reason they are called anonymous. Okay, these are functions that you can easily use when you don't want to create a normal function, or you simply want to use them inside certain expressions. For instance, let's create a function, an anonymous function, and call it int a, int b. Right, int a, int b, and inside this we're going to print a subtracted from b. So to call this function, it's quite simple because it does not have name and there is no way we are going to use it anywhere else. So we simply invoke it immediately after declaring it. So inside here we're going to add 3, 2. Okay, so let's save and run our code. Okay, 2 from 1 we get 2 from 3 we get 1. When we subtract 2 from 3 we get 1. Alright guys, so that's all for function, and that's all for this section. In the next section we'll go into object-oriented programming, and this is where we're going to learn a lot about classes and objects. Thank you guys for watching, and I'll see you in the next one. Hi guys, welcome to this section. And in this section, we are going to talk about classes. So classes are a blueprint for creating objects in object-oriented programming. So in object-oriented programming, everything is treated like objects, okay? And classes are what enables us to make those objects. You can kind of think of it as creating your own data types. So when you create an object, the object is called an instance of a class. So an instance of the class you create that object based on. So let's see some examples. I've already created a class file. So now we are going to create a class based on person. So let's say class person. And inside person we are going to have two properties. So let's go ahead and create string name. Now we don't want to set a value to this name, so we are going to make the variable to be null. Okay, we are going to make it nullable, and we're going to also set age, int age, in the same way age. Now properties are like variables inside classes. Okay, properties are what define what the object is, and methods are what define what the object does. So properties are the attributes, methods are the functionalities. So let's create a function that introduces the person. So we're going to say void intro. So inside the body of void intro, we're going to print hello, my name is name. My name is name. I am age years old. My name is name and I am 8 years old. So now we have a class called person, and based on this class we can create different kind of objects based on person.
or we can say we can create different kinds of person objects. So inside the person class, we have two properties and one methods. So name and age are the properties, intro is the methods. So like I said earlier, properties are like variables, and they are the one that describe what the person is, basically his characteristics. Now methods on the other hand are functions inside the class, and they hold the functionalities of the class. So you can kind of see properties as your skin tone, complexion, your age, your what's it called, the language, your nationality, and all that. Then methods are what describes what you do and all that, your career and every other thing. So let us create our object based on the person class. So to do that, we are going to come inside the main function, which we haven't declared yet. So let's create our main function. So inside the main function, we're going to say p1. Okay, because I think we are going to be creating multiple objects. So we're going to say p1 equals, let's say var, we need to add var. Var p1 equals person. Okay, so var p1 equals person, and now we can now say p1 dot name. Dot name equals John. Yeah, let's use John. Or let's say Mark. P1 dot age equals 30. So now to see what we've just written, we are going to need the method to tell us what it is, to tell us about the object. So we're going to say p1 dot intro. Let's save and run the code. So you have, hello, my name is Mark and I am 30 years old. Okay, and we can also create another object. Let's say p2. We can create as many objects as we want. So let's say p2. p2 equals, I should use var. p2 equals person. And p2 dot name equals John. p2 dot age equals 25. And p2 dot intro so let's save and run the code. So you see, my name is Mark, I'm 30, my name is John, I'm 25. So you see, based on the same class, we can create two different objects. In fact, we can create 1,000,000 objects, as many objects as we want. And all these objects, P1, P2 to P1 million, depending on how many we want, are all instances of this person class. Now, the next thing we are going to talk about is constructor. So in that, a constructor is used to initialize properties of an object. And constructors is kind of general to most object-oriented programming languages. In fact, all object-oriented programming languages. So we're going to check and create a constructor. So the constructor takes the name of the class. So we say constructor string name int age. So by doing this, we'll say int age. We'll say name. This dot name equals name. And this dot age equals age. So when we say this.name, we are saying this class here is this represents this class. So this.name represents the class property here, name. Now equals to name here is this argument or parameter we pass to the person constructor here. So this.name equals name. This.age equals age. So now when we come out here and arguments to the class, okay, to the constructor when calling it. So now for the name, we're going to say Sam, maybe. And for the age, we're going to pass 24. And for object 2 here, we're going to say Paul. And for the age, we're going to say 22, right? So you can simply print it based on these constructors by saying p2 dot intro. p1 dot intro. So now when we run the code, we're going to get 4 different objects, okay? Because here, because of the constructor we've added to our class, we can now add the properties directly here. So when we do that, we print it, and then we can come down here and reassign it again, the name to Mark, the age to 30. Then for P2, we simply add the properties inside the constructor. Then we come out here and print it. Then we reassign it again to John. So in the output, when creating classes, it's better for us to make the properties private, okay? Because we don't want to create properties in such a way that the users will be able to change it at will. So we want to make sure the properties of a class are private so that they can be modified from outside the class. And the syntax for this is simple. All we need to do is add an underscore before the property, okay? So now we come up here and add an underscore to this place, and we come to the this here, okay? So we just add underscore to all the places we've done it before without the underscore. Let me add underscore to everything. So let's save the code and run it. And we still get the output, okay? Even though now the properties are private, with this underscore, they are now private. And normally we should not be able to modify them from the outside. But you can see p1.name, we are still able to modify it outside of this constructor, okay? Normally now what we should have should be only these constructors. We should not be able to use this dot notation. Okay, by using dot notation, we can modify it, and that should not be possible. But the reason why it still works is that the properties were supposed to be private and inaccessible from outside of the class. Now, something important that you need to know is the private attributes, or let me say the privacy of a property, only takes effect at the library level in that programming language. So this means that since the class definition and the object implementation are in the same file, we won't get any privacy. And this makes sense because since the user can see the code of the class, which is the blueprint, so what is there to hide? So now what we are going to do is we will move the class definition into another file and then import it. So by importing it, we will be unable to see the properties from outside and modify this from outside the class. So let's go up here, cut this class definition. We're going to cut it, Ctrl X, and I'll create another file called test. Okay, test.dart. So we've pasted it here. And now let's go back to class and import it. Import tests. Okay. So now what happens? Immediately you can see in these places we try to reassign them to modify the properties from outside. You see, the setter name isn't defined for the type person. So it's impossible now for us to modify them from the outside. So the best thing to do is just to comment them out, because we are still going to reuse them later in this code. And now we are also going to comment where we modified P2. So let's comment all this out and save. Now when we run the code, so you can see my name is Sam, I'm 24. My name is Paul, I'm 22. So we can only declare the properties inside the constructors. We cannot modify them from outside the constructor. So now from outside the class or the constructor. So the next thing we are going to do is we are going to check some methods called getters and setters. So now after declaring the properties in our class as privates, getters and setters are methods that allow us to manipulate the properties of a class, or especially the private properties from outside that class. Getters, on the other hand, allow us to read the properties and modify them. Okay, so setters allow us to set the value of the property outside. Getters allow us to read and modify the properties. So what you are going to be doing is we are not modifying the properties directly. We are only modifying them through the function. So let's go back to our class declaration or class definition and create what we call getters and also setters. So we are going to write comments and say getters. And for getters, the syntax is simple, it's just a function. So say string gets name. Gets name. Oh, sorry. String gets name. Get name, and what we do is return name. Return name. Now we get these squiggly lines under here or an error. It says a value of type nullable string can't be returned from the function. So what should we do? Let's just make the function nullable also. So now there's semicolon and everything works fine. So for the age also, we're going to do get age int get age. So let's make it nullable also. So get age, return age. Let's save. And for setters, the syntax is also very simple. So let's write setters. And you come down here and say set name. Set name, and this one takes a parameter, or it will be taking an argument, because that's how we are going to be able to reset the properties outside the class later on. So we're going to say string name, right? So string name, then in the body of the function we'll say underscore name should be equal to name. So we also come down here and create a setter for the age. So say set age. And age underscore age equals age. And there you have it. So we can now go ahead and run our code inside classes. So now when we come and let's uncomment all these things we've commented initially. Let's comment everything, uncomment everything. So for P2, we are going to say, instead of P2.age directly, we are going to say P2.setAge, okay, equals 25, dot set name equals 22. Right, P2.setAge equals 25, P2.setName equals John. So we're also going to go for P1. Don't comment this out. So instead of going for the properties directly, we are going to be using the setters. We're going to be using the setters. And when we run the code now, let me set name for P1. So P1 equals dot the set name equals let's say Mark. Let's run the code. So you see our code works again the way it did earlier. And for our get age, now we can now use the get to read the properties. Okay. For instance, now when we come down here and we say print P1 dot get age. Okay, let's use print actually, because we need print to be able to execute it. Print age. Print P1.getAge. Now, unlike your normal function, remember when we were creating the getAge, it has no parenthesis here. So to also call it, we do not need a parenthesis here. So let's just go ahead and remove it. Now, in some cases, you can add this to it and maybe not. So let's Ctrl D and say get name. Get name. So now when we run it, well, we're going to get name. So you can see the age is 30, the name is Mark. So now we can now use our getters to get and read the properties of the class, while setters allow us to set the value of the class without actually using the class directly. And this is what we want, because we don't want the properties of our class to be modifiable from the outside. We only want them to be modifiable inside. So, but with getters and setters, the functions allow us to be able to see things from the outside, modify them from the outside, but without actually modifying the property itself. Okay, so all right everyone, that's all for this video. This course is simply meant to get you started with that programming, and there are so many other things we haven't touched and we did not really go deep into the concepts. So nevertheless, I'll still make another video about object-oriented programming, where we are going to go deeper and talk about things like factory constructors, and we're also going to talk about concepts like mixins and asynchronous programming using the Dart programming language. Please make sure to like the video and subscribe to the channel. Turn on the notification. That's where you can know every time I upload a new video, and I'm also going to be making those videos very soon. Alright, thanks for watching, and I'll see you in the next one.